language that we would like to introduce to you, because you'll be learning a web framework that is based on the Ruby programming language. The second thing that is special today is that Ajahn Atiwong will not be here today, so that means that I am free to talk about whatever I want. Just kidding. Oh. All right, let's get started. The reason why you want to study distributed programming or socket-based communication is because if you looked at your project carefully, you'll see that there are some requirements that will require you to know about socket programming. I believe it has to do with file transfer and, I don't know, maybe connecting to some server of your choice, but definitely something about file transfer. All right, so let's get started. What is distributed computing? What is distributed programming? Essentially, you see, all the applications that you guys have worked on so far, I think, have primarily been local applications. Applications that just talk to itself or just actually don't talk to itself, but actually doesn't really talk to other programs, right? We created applets, right? Applets, just an animation program. We created, what else? Hey. We created, what other things? Threads, right? Multi-threaded applications. That doesn't have to talk to anyone. But with socket programming, right? You're basically enabling your application to be able to communicate with other applications using socket as the mechanism, okay? So the reason why we call it distributed is because the entire, how should I say it? The entire, all the network of computers that talk essentially form the entire application, if you will, right? What are some of the examples that you guys can think of that make use of socket or are good examples of distributed computation in practice? Should be pretty familiar with them. Hint, internet. Okay, the internet, right? I mean, the internet is built on networks as a hardware and built on TCP/IP or a lot of protocols that we use, and we'll take a look at what we mean by protocol today. But I think the point that I want you guys to remember is that when we talk about distributed computing, I want you guys to have in your head essentially the internet. You have interconnected computers that talk to among themselves or talk to each other through socket or through some sort of protocol, right? And the point why we want them to talk, well, we want them to exchange information, right? And the beauty of socket programming is that for them to talk, you don't care that they all have to be running Windows, right? You guys know that most of the web servers out there on the internet today are running probably some variant of NIX operating system, whether it's Linux or Unix, right? And there are some Windows servers out there as well, but those are sort of like the minority. But the point is that because of the, for example, TCP/IP protocol, as long as two machines communicate with each other using the same protocol, the two computers can talk, even though they are running on different operating systems. Okay, So that's what makes the internet successful, in that it doesn't lock you into a particular technology, or it doesn't lock you in a particular hardware, right? As long as it is a computer, actually it doesn't, not computer or a PC in a traditional sense anymore, right? Because even your phones can be connected to the internet. So I think the point is that as long as both machines use the same protocol, they can talk, okay? They can communicate. So there are actually many more technologies or mechanisms than just these two, but the two that are pertinent to at least the Java technology are these two. The first one is called socket-based communication, and net. And this is what we're going to be teaching you today, primarily. And as it says on the slide, the unique feature of socket-based communication is that there is an explicit connection establishment among the two. And I'll show you what we mean by explicit communication that needs to be established before you can talk or communicate using the socket-based. And then there's another one called remote method invocation, or RMI for short. And this term was popularized by the Java framework or Java technology. It is different from the socket-based communication in the sense that it is really built for distributed programming, okay? As long as, and you don't need to have an explicit connection for the RMI to work. I mean, you will still be able to run the RMI application, RMI enabled application, even if other hosts are not running. But we just wanted, I think the point here is that we just wanted to throw the terms to you so that you are aware of what is out there for the Java technology. But the most important form of communication that we want you to be proficient in is the socket-based communication. So let's take a deeper look at what socket-based communication is all about. All right. So when we talk about socket-based communication, I want you guys to have this picture in mind. For this class, all that you need to know is that with socket, right, as long as you have your network, right, as long as the computers, second time, as long as both computers are connected to the networks where they are reachable, right, as long as they are reachable to each other, the two computers can talk to one another, okay? So what do I mean by reachable network? Are you guys familiar with the LAN, local area network? So that is, for example, an example of network that might not be reachable if two computers were to be connected to two different LANs. Because as the name implies, right, local area network, when you have, oh, my pen's all gone. So this is one LAN. So that's a network cloud and not the cloud as in internet cloud. So this is another LAN. And then you have computer A and then computer B. And then this is C. And assuming that both of these LANs are not connected to the internet. So this is the internet cloud now. If both of these are not connected, then the first question is, can we have computer A and B communicate with each other? Yes, right, because they're connected to the same local LAN or local area network. Can either computer A or B talk to computer C? No. Now, if I were to draw a line to actually connect both of these LANs to the internet, do you think that they can communicate now? Most likely, unless the LAN administrator is a bit turns up the firewall that disallows that from happening, right? Certainly, if they block ports, okay, it is possible that you might not be able to communicate with other computers of different LAN. What are you guys doing? It's okay. So we'll talk about what is a port, an IP address and all that in the later slides. But at the very high level, right, socket-based communication basically are two endpoints, right? Just like how we talked about how we have endpoint A and endpoint B, okay, between hosts. What we mean by host is just another term for computer or electronics that can talk using socket communication. And the whole point is that sockets allow you to send information or data back and forth between those two hosts. And we'll go over the APIs that allow you to send and receive data using socket later today. Sockets are ubiquitous, okay? By that I mean I'd say all modern platforms, if they have any hopes of being connected to the internet, they must implement TCP/IP or allow the developer to use socket API, because that's essentially how the internet is running today. They use IP protocol. Okay. So Java applications, of course, can use socket to communicate with applications written in another language. So we talked about today, I mentioned earlier in the previous slide that one of the reasons why the internet is so successful today is because it does not restrict you to simply use a certain technology, right? By that I mean, it doesn't force you to use a Windows server, for example. Your machine can run Linux, Mac OS X, or whatever, and you still can be connected to the internet, right? This is what we mean by the internet or the socket programming does not restrict you to a single platform. And not only a single platform as in operating system, right, or the hardware itself, okay? It also does not put restriction on the programming language that you have to use. Imagine that if you wanted to do socket programming and you had to only use assembly or you only get to use C++ or something, right? Probably not a lot of people are going to adopt that technology. So another factor why socket programming is so successful today is because it's implemented in so many different programming languages like Java, right? C++, C# certainly provides support for socket-based communication. And, or even Ruby, the programming language that we'll be learning today, okay? And this is just to give you a bit more info, but with all the technology that we have today, okay, I consider socket communication to be low level. By low level, let me make an analogy. Just like you guys all know what assembly language is, right? Yeah, machine level language. Again? No, your uniform. How come you didn't wear it today again? Who else did not wear จ้าเอ๋ย Man, bye, get in class. Okay, so 2 people violated the uniform rules today, huh? Huh? ห้ามใส่ Well, how about you start dressing just like your friends? Pinky is a good example. Or they'll, you're supposed to dress in the knitted uniform, no? Anywho, so where was I? All right, I was asking you guys if you guys know what machine language is like, or assembly, right? So at the very bottom of programming, we have what we call machine language or assembly, right? A higher level language than machine language, is something that is C, very close to the metal. But by close to the metal, I mean that the lowest level is hardware. Okay, at least from the perspective of software programmer. Because if you actually studied hardware, okay, programming, then there are many more layers than this, like Verilog or VHDL. Anyway, so we call this pretty lowest level for programmer. This is low-level programming. And then built on top of C, or a language that is of, how should I say, higher level programming language than C, is something like Java, which is what we are studying in this semester. So why did I talk about this? Why did I bring this analogy up? The reason is because socket. So this is TCP/IP or UDP. Actually, I'm just going to restrict ourselves to TCP/IP. You see, at the lowest level, TCP/IP is analogous to no, hold on. So you actually have like physical network. Okay, and I'm gonna come back to that later. Okay, so the reason why I made this analogy, or I talked about, the programming stack, is that you have an equivalent comparison if you were to look at socket as a higher level programming language. Because with socket, you don't have to really know how the TCP/IP protocol works. You simply just use the API provided by the language to facilitate the communication. But you see, I say with all the technology that we have today, okay, available, socket programming is actually a low-level a low-level way to implement internet-enabled or network-enabled applications. Because built on top of socket programming, we have what we call these things like middleware or RMI. And I think once you guys start implementing the socket programming, you realize that the downside of socket programming is that you are talking in terms of bytes. You're talking in terms of raw data, bytes, and you also have to. The hardest part about socket programming is not sending or receiving the data. It's actually handling the failure that happens because of something happened while the communication is ongoing. But the point here is that with RMI or middleware that exists out there, we can program we can do network program much easier, okay, than socket programming. So I just want you guys to remember that if you know, it's 3 a.m. in the morning and you're banging your head, like, why is it that this is not working? We want you to learn socket programming because it's a good foundation. But when you actually go to work in the field, most likely you will not have to, or I hope, you will not have to use socket programming anymore, because many companies build another layer, if you will, to make your job easier. So is that clear, the analogy? So I just want you guys to know that, you know, for this semester you get a chance to do something pretty low level using socket. All right, so in the previous slide, right, we had this diagram where we have two computers talking to each other, right, via socket programming. So the two computers that you see on the screen in the previous slide, they're not equal. Ned, Nay, go sit over there. Wow, I feel like a high school teacher right now, but I'm reassigning your seat. You guys talk too much. Go sit somewhere else. No, and Ned, you stay there. Is that going to work? Is that going to help? You're supposed to go somewhere else. Go sit with the French or something. Try to learn French. Hey, hold on. You're not going to have any notes to write on? I mean, you didn't print out any slides? Huh? What? Oh my God. Okay. Okay, this is going to be my new strategy for breaking up the people that talk a lot. First is isolation. Asylum. No, just kidding. So, for two computers to communicate using socket, one must play the role of a server, while another must play a role of a client. So I'm going to denote, I was going to write S and client. Okay, so server, client, and from now on, I hope you guys will know that whenever I write S, I mean server, and a C stands for a client. Okay? Let's talk about the reason why they call a server and a client a client. I mean, you know, you guys are the next generation now. You guys are probably about 11, 12 years younger than me. I mean, back in my days, right, server was not a well-known term. But I'm sure that you guys, you know, growing up in this internet age, must have heard of the term server. So what do you think is a server? Can someone give me an example of what is a server? That you guys, anything. I just want an example. Okay, I didn't really mean that you have to learn French. Oh. Yeah, maybe I should isolate you. Maybe you have a problem just like Ned. Maybe you want to come sit here. But okay, I'll give you one more chance. Huh? Right, but right now, you need to learn this too, because if you don't know this, then you won't be able to implement some of the requirements on the class project. And that actually applies to all of you people that are not planning to listen today, right? Because socket programming can be a bit tough, okay? So pay attention. All right, so we were talking about, or I was asking you guys, can you guys give me an example of a server? Anything? Come on. Huh? So, an example, right? Course, what? Waitress?
Server.
Or fortress?
No,
Wait. Ha ha. So do you think a waitress is a server? Yes. Thank you for that example. What do you bring? So, okay, a waitress is a server, definitely. But how about a computer server? Thank you, good for spotting. Huh? Domain name server, right? DNS. What does a DNS do?
Resolve IP to resolve Linux into IP.
Right. Did you guys know that there's actually a type of computer out there that will translate the host name that you put into your web browser into an IP address? We call that server a domain name server, or abbreviated as DNS. Now, some of you might not have heard of IP address before, but that's okay. That was the point of that was just to show you or give you an example of what a server is. Can someone else give me another example of a server? Come on.
Website.
Okay, so there's Courseville. What's that? What else? Hey, come on, something that you guys use every day. Let's talk about something you guys use every day. Facebook. You guys think that Facebook is a server? Yes, right? So now that we've mentioned a few examples, right? DNS, Facebook, Courseville. What are the, how should I say, defining characteristics? Why do you know that these are servers? What is your explanation? What's your rationale? Right. There's a reason why it is called server. The reason is because it serves information. So let's take the Courseville, right? Or Putti, how Putti likes to lovingly call it Curseville. Because every time there's an update from that server, you guys always curse, right? Especially the assignments that I assigned, like last night.
That's the reason why your hard disk is there.
oh, you hacked it? No, just kidding. So let's take Courseville. Okay, what kind of information does it serve to you, poor students? Course information, but we serve that once in the beginning of the class, but what do we weekly serve to the students in this class? Huh? Curse. No, that's what you send back to us. We never curse. Homework assignments. Okay? We use Courseville to assign homework to you. Okay? What else? Is there any other? PDF, right? In other words, this is what server does, right? Server sends information. Servers provide information. Okay? Just like how a waitress will serve you the food. Now, who's on the receiving end? What's the term we use for the receiving end, the receiver? Client. Okay? So I think as long as you guys understand this explanation, you guys should have no trouble understanding this slide, right? So you have one end must be a server and one end must be a client. A server serves information, provides information to all connecting clients. Okay? All right, so on the next slide, we are going to show you the interaction between a server and two clients, just so that you see the picture of what the communication is like. So we have two clients in this example. And we have one server that is currently, waiting for a incoming request. By incoming request, we mean that for two hosts to establish a communication, the client must be the initiator. It must attempt to connect to the server. Okay, so that's what's going on for point 2. Now I think I forgot to mention, okay, if the server was not waiting there, waiting for requests, okay, then when the client made an attempt to connect, the client would not, right, be able to connect to the server. So for the communication or for the connection to be successful, the server must, and I emphasize, must be there waiting for the incoming request. Okay? So now, once the client 1 establishes or makes a connection, then the server, since it's waiting there, it will see the request, okay? And it will create what we call a socket. Now, in this example, socket, when we say socket, we're actually referring to an object, okay? Socket is a class in Java that you can instantiate, okay? So here, the server instantiates a new instance of a socket, okay, to handle the incoming connection. Whoops. And then once the server accepts the connection, so that's a method call, okay, that the server can make, then we say that a connection has been established between the server and the client. Okay, so that, if you guys remember in the previous slide, we talked about how socket communication is a sort of communication that must be established. Ja Ơi, would you like to come sit in front to get personalized
Thank you.
physical? So socket communication, you must establish the connection. Think of it as a telephone line, right? It is not, okay, so since there are 2 types of communication that I want you guys to be aware of, and socket or TCP/IP falls into this category. You have server and client. So in this form of communication, a connection is established. Imagine like a telephone line, right? That is one form. Nay, so how many words have you learned so far? Come here. Come here. Yeah, come sit with Puti. I think you need to learn less French and learn more Java programming. And I even put the microphone for you. Maybe you can help answer some of the questions. And those other students, okay, just be careful because I also will move you and come sit here. So you're going to talk to me now?
There is someone sitting right here. We can talk.
Whoa. Whoa. So this form of communication needs to be established. But there's actually another form of communication that does not require an established communication. It's just 2, how should I say, 2 hosts, and then they communicate by simply just sending data to another host without any established communication. Okay, so I want you guys to have this picture. So I think this is sort of like, I don't know what the right term is, but let's just say ad hoc. Okay, you know, you send something and you don't expect anyone to receive that data. In fact, you might not even be aware that this person is like out there. But if I'm talking about established, connection that is established, we're talking about this, like a telephone line. Anywho, so now we're at number 5. So a connection has been established between S1 and C1. But you see, the unique thing about server, if you implement it correctly, okay, is that you can handle multiple clients all at the same time. So without knowing anything, I would like to test your knowledge and ask you, how might one implement this handling of multiple clients at the same time using the concepts that you guys have learned before? Does anyone have any ideas how you might implement this on the server to be able to handle multiple clients, and here's the keyword, at the same time? Thread, right? So multi-threaded server is the norm. I don't want to say common, I want to say that it's the norm today. Imagine, okay, let's go back to Facebook as our example. Imagine if Facebook server were to be a single threaded server. It will be able to only handle one client at a time. How would you like that? You would love it because you can build like a competing product, and then I see. You're not supposed to love it for this example, right? If the server was only able to handle one client at a time, nobody would want to use that server, okay? So, and you guys want to pay attention to this because I don't know if you have looked at the homework, but for the homework you are required to implement a multi-threaded server, right? If you guys have looked at the homework prompt. So this is what we mean by S can still wait for other requests, okay? So here, client 2 is also attempting to make a connection with the server. So let's see what happens next. So just like what happened with client 1 and the server, right? Now we have client 2 simply doing the exact same thing. Server now receives a request from client 2. It creates another instance of socket, and it has to accept that connection to establish the connection. And now with that, you are able to exchange data between the server and the client. So all this might sound quite abstract. That's okay. We have example code that came with this example or this explanation. Now, but before we look at the code sample, I want to point out another really important concept when you're talking about socket programming, and that is IP address and the port number, okay? So who here has not heard of IP address? Okay, good. Has not heard of IP address. What is IP address? For those of you who did not raise their hands, like, good. What is IP address? Why do we need an IP address? Okay, IP stands for Internet Protocol, but why do we need it? Okay, IP address is a unique ID that is assigned to each computer. With that, it allows you to locate or talk to the machine. So if you put in some IP address like that one, right, tries to connect to that IP address, that actually is some machine that's out there on the internet cloud that you can connect to. I think the best way to understand an IP address is like there's a reason why it's called address, right? Oh, with the new haircut. Is that, hey, wrong uniform, come sit here. She's sitting here not because of her uniform, but because she talks too much. Try to learn French in class. Not a good thing. Hey, I'll pick on you. So what is an IP address? What is an IP address? That's a bad. Okay, that's a good. That's an okay explanation. That's good. What do you think? What do you guys think of when you guys hear address? What is location? You guys heard of mailing address, right? What's your mailing address? Thailand. So suppose if I knew where he lives, what can I do?
Rob my house.
So knowing his address, I can locate where his house is. Is that right?
Yeah.
Right? By consulting something like Google Map, I probably would just put in his mailing address or his address into Google Map, and then I would be able to find out where he is. You see, IP address is exactly the same concept. Knowing the IP address, you can consult something, and that something will tell you exactly where that computer is. Okay? So when you think of IP address, I want you guys to think of or remember mailing address. IP address is just simply a sequence of numbers that allow you to locate and identify the location of that machine. But IP address is not all there is to it. There's also something called port number. So those of you who are avid, ROPG or MMORPG, multiplayer computer programs online, does this term port ring any bell? So who plays, I don't know, Warcraft, World of Warcraft, or .A, or do you guys play any of those games anymore? No? A bunch of liars. You guys ever played Command and Conquer? Or, not the old one, there's Command and Conquer Generals. In fact, the new one is coming out too. Command and Conquer General 2. Right? No? So nobody here plays computer games at all. A bunch of liars. Too bad Fiam is not here. He is an avid World of Warcraft. So what game do you play, Bryn? He pointed at you, so blame him. Blame Pacific. What game do you play? Okay, that's a good answer. Any one of you has to configure port number? Ever had to configure port number? Okay, port forwarding, okay. Right? I'm going to explain. That's why I'm asking you guys now. So for those of you who have, dabbled with networking, like hacking, or gaming, right, that needs to be connected to the internet, I think that you probably have seen port number, more or less, especially when And you can't miss it if you have to configure your router, the router at home. So what's the port number? Why do we need it? Okay, look at that picture right there. So we already talked about how a server, right, can accept connections from many different clients. Okay, good so far? And you guys know, right, that each IP address is mapped to one and only one machine out there on the internet. In other words, it is illegal for the same for two servers to share the same IP address. So let's say IP address is 192.1 and 192.1 here. This is not allowed. Coming to class 45 minutes late. Just kidding. It is not allowed. This is not allowed. By that I mean you cannot have two computers that have the exact same IP address. So let me fix that. So now you guys know that. So if you guys follow that rule, okay, if I wrote a program that is running on this server that can communicate with these clients, and since we talked about how we can only have one IP address for one machine, right? My question is this: what if on this server we also ran another application that is listening on that IP address? By that I mean, this client, right, for it to locate and talk to this server, it must have put in the server's IP address to locate it, right? But then how do you specify which program you want to talk to? Do you guys see what I mean? Because how would I be able to specify, okay, so let's say this program we call A and this program we call B. All right, I put in, as a client, I put in 192.1. Okay, I know that I'll be talking to this machine, but how do I specify which other two programs I want to talk to? And precisely that is why we need a port number. Because with a port number, okay, so I'm going to erase this and I'm going to just sort of enlarge the diagram. So I'm going to erase this too because I think you guys already got the notes for this. All right, so we have, back to our previous example, we have server listening on 192.1 and this client is attempting to connect to that server. But I already told you, right? On a single machine, you can run limitless number of applications. You can run multiple applications on the same machine. And we call this application A, application B, application C on this server. This client wants to talk to, for example, okay, this is bad. I should have just used A, B because we have two C's. All right, for example, if I wanted to talk to application B, how would I be able to specify that? How do you talk to application B? You have the IP address. You know that you'll be connecting to this computer, and this is another computer. This is 192.2. So how do we connect to this? How do we choose which of the programs we want to talk to in? How do we, as a client C, now I'm connected to server S. What do I use to connect, to choose which program do I want to connect to? Port number, right? That is what we use to select. So I said that we use port number, but how do we achieve that? Well, for the server programs that you write, you have to specify what port number that server is listening on. So, for example, you might have a server program that is listening on port number 8000. Another program might be listening on 8001. So now the picture is complete because you see, for a client to connect to any server, it needs to have two information. It needs to know the IP address or the host name of the server that is connecting to, as well as the port number. So as a quiz, we are trying to connect to program B. What is the port number that the client should use in this example? NIT 8001. Does this make sense? Does this make sense? The explanation of IP address and port number? Because this is the most important information for you to know and understand, because then you can use it to do your socket programming. Does anyone has any questions so far? Geez, take it outside. You guys do not sit together. Hey, Em, how about you go sit with Naya? Oh, no? Oh, okay. So you see, this is why we say that a machine may run multiple server programs. Port numbers is necessary to distinguish different servers running on the same host. Now, I'm sure that all of you have heard of the term firewall, right? Right? Firewall. Ha ha. Ha ha. I want to explain real quickly how do you prevent hackers from connecting to your computer. I mean, it doesn't really, it still gets through, but you see, now that you guys understand that you need two things to connect to a program, right? One, you need the IP address. Another one, you need the port number, right? This is why to prevent such connection from happening, people create both software and hardware we call firewall. What is a firewall, or what does it do? Essentially, it is simply just a set of rules that looks at all incoming connections, okay? And then if you say that, if you set a rule, for example, to say that disallow all 8001 connection, when client C attempts to connect to this program, firewall would prevent that from happening. This is why if you look at your router, and when sometimes if you had problem like running some program, especially your games, something like it's unable to connect to the internet or whatever, this is why they always say check your firewall setting and ensure that that port number is open or this port number is open precisely because of this, because firewall prevents established connection from happening. So you don't need to know that for the final, but I thought of mentioning it to you anyway. And just because it's firewall doesn't mean that there's something like burning, okay? It's just a term. I don't know how or why they call it firewall. Yeah, why don't they call it ice wall, right? All right. So, in the next slides, we're going to be looking at the APIs that you have to use for, you have to know for your final, but not for this homework, because if you guys look at the homework, you guys will know that none of these APIs will be helpful or useful, right? And this is why I'm trying to speed up and finish this lecture within maybe 15 minutes so that we can get a head start for. Or you guys play any of those games anymore? No? A bunch of liars. You guys never played Command and Conquer? Or not the old one, I mean, like, you know, there's Command and Conquer Generals. In fact, I mean, the new one is coming out too. Command and Conquer General 2. Right? No? So nobody here plays computer games at all? A bunch of liars. Too bad Fiam is not here. He is an avid World of Warcraft. So what game do you play, Bryn? He pointed at you, so blame him. Blame Pasif. What game do you play? Okay, that's a good answer. Any one of you has to configure like port number? Ever had to configure port number? Okay, port forwarding, okay. Right? I mean, okay, yeah, I'm going to explain. That's why I'm asking you guys now. So for those of you who have, you know, dabbled with networking, like hacking, or gaming, right, that needs to be connected to the internet, I think that you probably have seen port number, more or less, especially when, and you can't miss it if you have to configure your router, you know, the router at home. So what's the port number? Why do we need it? Okay, look at that picture right there. So we already talked about how a server, right, can accept connections from many different clients. Okay, good so far. And you guys know, right, that each IP address is mapped to one and only one machine out there on the internet. In other words, it is illegal for the same for two servers to share the same IP address. So let's say IP address is 192.1 and 192.1 here. This is not allowed. Coming to class 45 minutes late. Just kidding. It is not allowed. This is not allowed. By that I mean you cannot have two computers that have the exact same IP address. So let me fix that. So now you guys know that. So if you guys follow that rule, okay, if I wrote a program that is running on this server that can communicate with these clients, and since we talked about how we can only have one IP address for one machine, right? My question is this. What if on this server we also ran another application that is listening on that IP address? By that I mean, you know, this client, right, for it to locate and talk to this server, it must have put in the server's IP address to locate it, right? But then how do you specify which program you want to talk to? Do you guys see what I mean? Because how would I be able to specify, okay, so let's say this program we call A and this program we call B. All right, I put in, as a client, I put in 192.1. Okay, I know that I'll be talking to this machine, but how do I specify which other two programs I want to talk to? And precisely that is why we need a port number. Because with a port number, okay, so I'm going to erase this and I'm going to just sort of enlarge the diagram. So I'm going to erase this too because I think you guys already got the notes for this. All right, so we have, back to our previous example, we have server listening on 192.1 and this client is attempting to connect to that server. But I already told you right? On a single machine, you can run limitless number of applications. You can run multiple applications on the same machine. And we call this application A, application B, application C on this server. This client wants to talk to, for example, okay, this is bad. I should have just used A, B because we have two C's. All right, for example, if I wanted to talk to application B, how would I be able to specify that? How do you talk to application B? You know, you have the IP address. You know that you'll be connecting to this computer, and this is another computer. This is 192.2. So how do we connect to this? How do we choose which of the programs we want to talk to? How do we, as a client C, now I'm connected to server S. What do I use to connect, to choose which program do I want to connect to? Port number, right? That is what we use to select. So I said that we use port number, but how do we achieve that? Well, for the server programs that you write, you have to specify what port number that server is listening on. So, for example, you might have a server program that is listening on port number 8000. Another program might be listening on 8001. So now the picture is complete because you see, for a client to connect to any server, it needs to have two information. It needs to know the IP address or the host name of the server that it's connecting to, as well as the port number. So as a quiz, we are trying to connect to program B. What is the port number that the client should use in this example? NIT 8001. Does this make sense? Does this make sense? The explanation of IP address and port number? Because this is the most important information for you to know and understand, because then you can use it to do your socket programming. Does anyone has any questions so far? Geez, take it outside. You guys do not sit together. Hey, Em, how about you go sit with Naya? Oh, no? Oh, okay. So you see, this is why we say that a machine may run multiple server programs. Port numbers is necessary to distinguish different servers running on the same host. Now, I'm sure that all of you have heard of the term firewall, right? Right? Firewall. I want to explain real quickly how do you prevent hackers from connecting to your computer. I mean, it doesn't really, it still gets through, but you see, now that you guys understand that you need two things to connect to a program, right? One, you need the IP address. Another one, you need the port number, right? This is why to prevent such connection from happening, people create both software and hardware we call firewall. What is a firewall, or what does it do? Essentially, it is simply just a set of rules that looks at all incoming connections, okay? And then if you say that, if you set a rule, for example, to say that disallow all 8001 connection, when client C attempts to connect to this program, firewall would prevent that from happening. There are websites, I guess, or service out there that you can upload your program so that you don't have to leave your computer on all the time. Is that what your question was? But you see, when we said like Ajahn Atiwong has to leave his computer on all the time, we're not talking about his computer, okay? Because Juฬา, right, they have a bunch of servers. And Ajahn, I don't think Ajahn Atiwong uses his personal computer. He probably uploaded his program onto one of the Juฬาservers, and then you guys are connecting to that Juฬาserver, not his not his personal computer. Does that answer your question?
Yeah, but is it a physical server or is it like similar to cloud?
Wow, that's a very good question. For this assignment, I can tell you that it is an actual physical computer, just one instance. The only reason why you need cloud is because when you have to scale, like Facebook is not running on one server, right? They have 1,000 or 10,000 of servers running. But you see, okay, good question, right? The reason why it's called cloud is because like this is Ploy and this is Nui, right? And these are a bunch of machines that is running Facebook. And it's not all running the same application either. Let's not take that as the simplistic view, because what's really happening is that in today's world, you have a bunch of computers and they build a platform as a layer. So Facebook, imagine like a program that for it to run, it doesn't run on just one machine, it runs on like gazillion machines. They build an abstraction. And then this is the cloud. From your point of view, you're connected to some machine, but you don't know which machine. So I wanted to make sure that you have this picture in your mind but from your point of view, you're connecting to one, right? You're connecting to a single Facebook. But actually behind the scene, that web page might be talking to 10 different computers. But this is not what's happening for your class project, okay? For your class project, I'm sure that Ajahn Atiwong wrote the server program and he deployed it on one of the Juฬa's machine, and then your program just talked to that single machine. We don't have all these cloud indirection layer. Well, are you talking about this or that case?
No, Facebook.
Okay, you see, in the cloud, one of the selling points of the cloud is that they built in this concept of redundancy, right? Let me explain clear by a really simple example. Suppose I built a Facebook application. To have redundancy, you simply deployed it on 2 machines so that if this machine crashed, you still have this as a backup. So to answer your question, if one of the machines died, most likely Facebook is going to be alive and kicking, running just fine, because of the concept of redundancy.
But you said that each user will be connected to different machines, right?
Right,
So if one machine just crashed, so what about the user?
right. So for that user, then, you guys ever seen, so who here uses Twitter? Maybe Facebook is not a good example, but who here uses Twitter? Or you guys know what Twitter is, right? You guys ever seen that whale when you try to connect to search Twitter and then you see the whale instead of like being able to post your messages? That is what happens when one of the computers die. You see, Twitter had a very serious problem where its servers is not able to handle all the clients that are connected to its service. And that's why you see the whale. Okay? This is what happens when your computer died, or when one of the servers died. The client will not be able to access the service. So coming back to the Facebook example, yes, so you might see something like if the server really died, you might see something like you try to make a post to your wall and it was not successful. So that's how you would experience it. But maybe other parts of your Facebook webpage might still be operational. For example, if you made a post here, that didn't work, but this feed updates might still be working. Does that answer your question, more or less? It's very complicated, and all these are actually just my thoughts. This might not be how Facebook implements, but the concept still stands. Redundancy is simply having multiple computers that do the exact same thing in the event that one or more machines failed. So I'm going to show the code now, but before we do that, I want to ask you guys, anyone has any questions about the behavior of this program? Okay, maybe I'll just show it. Whoa. How do you like that? This is why I use ITER. So first, before I lost you guys, on the left-hand side, okay, oh, it's not full screen. On the left-hand side, I created a server, okay? I type in Java. Maybe I should just do this for now so that you guys can see. And then I do this. Okay, this is the server, and we are going to be running the client here. Whoops. All right. So what I just did was I ran the server first, right? And it said that it was waiting for connection. And then I ran the client down here by typing Java echo client. The very first thing is that I think this probably is the first time this semester where to run an application in C, it does something meaningful, you have to run two separate applications. So I think I want to convey that to you, that for a server-client program to work, you must have two programs running. Well, it's not quite true, but at least that's how this is set up. Okay? So we have two programs running, and what can we do with this application? Well, you can type in anything, right? And then it will be echoed on the server, right? So I type in, right? And then essentially the text that is typed on the client will be echoed by the server. Now, the thing that is really cool about this program is that, oh crap. The thing that is cool about this program and that we expect from you is that the server is multi-threaded. In other words, it can handle 2 clients at the same time. So if I were to type in something here, you'll see how the client, we get something from client 1, right? And then if I type something here, then you see, so client 1 and client 0, actually those messages get printed out from different threads. You can imagine that there are 2 threads running right now on the server. So you guys see the behavior of the program, and then to quit, you simply just type in bye. And you see how the server can detect when the client leaves. Okay? So this is very much like how your application, your final project application is supposed to behave. It will have to be something like this. This is why I hope that you guys have been paying attention, because now we're going to be looking at the, the code real quickly.
Why is there server there?
Where?
In the test file.
Oh, this is actually for another lecture. You don't have to. So we're going to spend just a bit of time, okay? So Echo Server, this is the amount of code that you have to write to allow the server to be multi-threaded and to be able to handle the client. Huh? Right, I've already checked this into GitHub, and it's in the source directory. If you look at my GitHub, you'll see SRC. Both of these codes should be there for you guys to clone. All right, so what happens? Essentially, you create a server socket that listens on what port number? Okay, so 10,008, right? And then we'll print out connection socket created, and then you see while server continues, right? So this is the while loop. We would what? We would accept, waiting for connection, right? And then each time that we get a new connection, we would instantiate a new class called Echo Server, which is essentially this class. Yes.
Switch to your program.
So you see, this is the power of network programming, right? Putty is actually connecting to my machine right now. It's connected. No, he's connected to my machine. So this is like a chat room, isn't it? You guys actually, if you guys have the program running, if you guys had a computer, you guys can run the same program and connect to my machine. Is that clear? Huh? Can you connect? No, not yet. All right, let's finish this quickly. Okay, you would need these I/O exception because a lot of these methods will throw exception. Okay, so this is just too much, this is why I don't like Java too much. But anyway, so Echo Server is a thread, okay, and you see the start method essentially makes the run method, okay, makes the run method get called. And then here is essentially the same thing that we saw in the previous slide, and read line is how you would read a line from the socket. And then you just simply print it out, okay? So that's the server. Let's take a look at the client. Normally, client is easier to implement than a server because normally when you're talking about a client, you don't have to have multi-threaded as part of client. Server, you do. So how do you write the client? Well, client will simply just connect to the, hey, Puti, how did you know my IP address? Oh man. So you would create a socket, right? Okay, you guys want to write this down? 127.0.0.1 refers to this machine. This one, 127.0.0.1 refers to this machine. By that I mean this client will always connect to the server that is running on this machine, the machine that it's running on. Another name for this 127 is localhost. This, and it has to be lowercase, I think. Localhost. Okay, so then you create, from the socket, you create this printer, writer, and buffered reader. And from there, you simply just, read what the user wants to type, and then just send it to the server.
อาจารย์แล้ว1.0.8
What was that?
เอาพอร์ต but how do you know?
Well, you see, this is the agreement between the server and the client. The client must know the server's port number, and the server must sort of like tell all the clients what its port number is. So when you guys do your class project, pick a port number for your server and client so that they can communicate.
So like when you initialize,
Mm-hmm.
or mode is pick a random number.
Yeah, you can pick any number, but my suggestion is pick anything perhaps bigger than 10,000. Because port 80, for example, is used by like web server. So as a rule of thumb, pick all port numbers that are greater than 10,000. You'll be safe. Is that clear?
And the 127.0.0, is that the address that you can find on your computer?
Yeah, that's like a hard-coded address on your computer. 127.0.0.1 is that machine's IP. No, not. It's the local IP address of that machine. Now, what do I mean? Remember in this slide, on the internet, you'll never see a machine that has this IP address. That IP address is reserved to mean localhost. Is that clear?
So if I write this program on my computer, do I have to change to some
Other number? No. Because when I say this machine, I mean that your machine, anybody's machine, it refers to the current computer.
Why do you use local?
When do you use or why?
I mean, why not?
Because like some people might dislike typing 127.0.0.1. They might just want to type localhost.
Yeah, why not like 192?
You can, but you see, IP address do change. When you connect to the Jula network, you turn off your computer, you turn it back on, your IP address changes. This is why you don't want to tie it to some IP address that the network assigns to you. You want to just say that, look, this program, or I'm trying to connect to this program running on this machine. That's why you use 127.0.0.1. It doesn't vary. Okay, so that's all that I have for the socket programming. And now we're going to move on immediately to the next lecture. No breaks yet. Nope, not yet. Hey, 5 minutes. Come on.
Come on, yes. Come on, yes.
No. The next thing that I want to talk about is Ruby. Okay?
Top team.
Yes, Taptim. Taptim is Ruby in Thai, by the way. Why do we have to study Ruby? I will show because two things. First, your current homework assignment, homework number 9, I think, you need to use Ruby, the programming language. That was loud. Secondly, you'll need it for learning how to. The last lecture will be about web framework, and the programming language for that web framework is written in Ruby. This is why I want to teach you guys the foundation, the basics of Ruby, so that when we actually finally learn about SOA, about web framework, you guys will have a basic understanding of how the Ruby programming language is. And also, because I think that Ruby programming language actually is very useful. You'll find many things that are very different, and yet it helps you to program a lot easier. Okay? So let's take a look at what Ruby programming language is. And let me tell you, the very first thing that you should understand is that the Ruby programming language is completely different from the Java programming language. And I think as we go through the features today, you'll see why I say that. Because first of all, Ruby programming language or the entire environment is dynamic. By dynamic, we mean that the type is dynamic and the runtime is dynamic. And I'll show you what I mean by dynamic in the later slide. And because it's dynamic, that's why it's interpreted. Okay? You can have, and I'll show you a concrete example as well. Okay, a paradigm, unlike Java where everything is OO, in Ruby, everything is an object too, but you're not required to declare everything with a class. Like I said, I'll show you a concrete example to point out the differences in the later slide. Like Java, it is also object-oriented, so there's a concept of class, inheritance, and all the features that you would normally expect to see in OO. But we don't have, or Ruby does not have multiple inheritance, just like Java. And it's functional. And I'm going to show you what we mean by functional later, but we don't need to talk about it right now. Compared to Java, Ruby is open source. By open source, we mean that this programming language is a collaborative effort. Many programmers around the world work together to add features to this programming language. Java, on the other hand, is a design by committee type of programming language. It's backed by one of the largest corporations in the world, and that is Oracle, right? But behind Ruby is not a corporation. It actually is a group of people, actually many group of people. And it is the first programming language that gained worldwide popularity, and that it originated from Asia. So do you guys know from which country Ruby originated from? Japan. And much like, okay, moving on, and much like Java, it is cross-platform. So the same Ruby program that you wrote can be run on Windows, OS X, Solaris, Linux, Unix, what have you. So many different, and even today there are people that deploy Ruby programs on iPhones, okay, on Smartphones. A few of you complain about how like, hey, you know, you like to save, not have enough time to talk about the most important stuff that you need to learn in the later slides. So I put together the most important thing that you need to learn and to understand in the first few slides. Because when you guys go to look up this information on the internet, and if you try to read and understand it, it's actually a lot harder compared to someone actually explaining to you. Now, the stuff on the later slides, on the other hand, you can look it up on the internet, and you know, with your current understanding of programming languages concepts, you should be able to understand the later slides with no problem, I hope. So let's take a look at the stuff that I put here. To understand Ruby, you must first understand the Ruby ecosystem. By that we mean the tools that come with Ruby. Is it time for break yet?
Yes.
I'll just mention it briefly, and then we'll go we can have a break. RVM, okay, is a program that you can install on your machine that will help automate and manage Ruby programs or Ruby runtimes on your machine. Those of you who did your concurrency homework, you guys know that you guys had to install what? Java's version 7, right? You guys had to go to a website, download it, right? But you see, and it was a bit tedious, right? Because like you had to install and go through instruction. But you see, with RVM, this is a program where you can specify from the command line what Ruby version you want to install and what runtime you want to have currently running on your machine. So it helps simplify that process of picking what version of Ruby you want to run. Ruby gems. Any one of you has ever tried to download like a Java library and integrate it into your program? Well, Ruby gems is a program that will that simplifies the process of downloading programs off of the internet by, again, just specifying it in the command line as well. And lastly, Bundler is a program to ensure that when you build your Ruby program, it uses all the right version number, because different library gets updated all the time, right? But you want to make sure that you run the library version number that you developed your program with, because future version might not be compatible with your program. Anyway, so I just wanted to sort of give you a basic understanding, rundown of each of these tools that we'll go over in details. Now it's past 10:30, so you guys can have a break, and we're going to start promptly at 10:45. 10:45, go, because we have a lot to cover. Go. And it gave me a lot of headache. For those of you who ran into that problem, I might just let me know so that I can tell you what the problem is. If you guys don't want to run into this headache, installing Ruby version 1.9.3 is okay. 1.9.3 will work as well. Some of you might ask like, hey, how come there's other things like, you know, JRuby, GoRuby, all these, Rubinius? These are simply just different runtimes, okay? But the one that you will be using for this class is the MRI Rubies, okay? So, how do you know if you have your Ruby installed correctly? So let's say that you install Ruby version 1.9.3. When you type in Ruby -v, you should see the version number on your screen. Okay? All right, so that's a quick rundown of what you can do with RVM. Like I said, these tools or these commands will come in handy. And I even included the URL that you can follow to go through the installation instruction. It's on the bottom right of the slide. We are going to keep going now. Paint your next. All right, RubyGem. RubyGem is another tool, just like RVM, that allows you that you run from the command line. And the reason why you want to use RubyGem is because it simplifies the process of installing Ruby gems from the internet. First thing first, in the Ruby world, we don't call things libraries, we call things as gems, just to fit with the theme of Ruby, since Ruby is jewelry. So think back to the days that you were using Java, right? If you wanted to use a library off of the internet, you must go to some website to download that library. And it comes in forms of source code or jar file. You download that, and then you have to go to your download folder, grab the jar file or the source code, compile it or whatever, and then link it, right? Include it as part of your Eclipse project jar libraries. But you see, with Ruby gems, that process is streamlined for you. So let me show you how, for example, you would install a library or a gem from the internet. And this is going to be live demonstration. So, the gem that I want to install for this example, let me take off this, hold on, slide, edit. Oh, right here, hide, comments, hide. Okay, so the library or the gem that I want to install is called Maruku, okay? This gem allows you to convert from the Markdown markup language to be an HTML document. How do you install it? So let me show you. Oh, let's see. Oops. Okay, so how do you install this? Very easy. First, make sure that you have gem installed on your machine, right? As long as you can type gem, you're good to go. Now, if you want to install Maruku, you simply just execute this command, gem install Maruku. And if God is on our side, then this will be successful. So you see how gem, not only that it tries to install Maruku for you, but it also works out the dependency. Because a lot of times, libraries depend on other libraries, right, or other gems. It will take care of installing all those dependencies for you as well. So how do I know that Maruku is now installed? Well, if I type in Maruku right now, it actually works, right? Like it doesn't do anything because you actually have to supply some input, right? So we're going to stop that, and we are going to use it, right? You can either type Maruku and then pass it the Markdown document, okay? Or you can run it from the Ruby program. But let's take a look at how you would how you would use Maruku gem in the terminal. So let's go to So I have here okay, So I have here I've prepared a markdown file for you guys already, and it's called example.md. So I'm going to remove the previous HTML that I generated. So let's take a look real quickly at what the example markdown looks like. So this looks like a regular, so a markdown or a .md file is just like a regular text file, a .txt file, except that it actually has syntax associated with it. You can actually have a program to transform this text document to look like something that looks more like an HTML document. So the point is not to show you what a markdown document is like, but to show you what happens when you use a gem installed from the internet. So you type Maruku and pass in the markdown document. Oh, crap. So it generated the example.html. Let's take a look at what that does. By the way, for those of you who use Terminal on the Mac OS X, to open any file, you can just type in open, and then it will attempt to open that file using whatever default application. So, for example, you have HTML file, right? We can just use open and see what program it uses. My computer, I set Chrome to be my default web browser. That's why it opened the HTML document using Chrome web browser. So you see, essentially what Maruku did was that it transformed example.md from this text file into this, an HTML document. So the point is to show you how easy it is to install a gem from the internet. You will simply just type in gem install Maruku or whatever gem name that you want, and then you can use it from the terminal program, or you can use it within a Ruby program. Now, how do you uninstall a gem that you just installed? Well, very easy, right? Should be intuitive. Oh, I messed up. So to uninstall, you would simply just type in gem uninstall and then passing in the gem name that you want to uninstall. There. You see how easy it is? So you don't have to like fiddle around with the downloaded jar. To simply uninstall something, you would just type it into the terminal. And this is the power of Ruby gems that I wanted to let you guys know. All right, next thing is Bundler. Bundler is simply a program that tries to maintain a consistent environment for Ruby applications. It tracks an application's code and the Ruby gems it needs to run, so that the application will always have the exact gems and versions that it needs to run. Let me demonstrate using the whiteboard what we mean by this. Suppose you wrote a program in Ruby that makes use of two libraries. Gems. So this is gem 1. Okay, no. I'll just say gem. Let's call the gem is like mark. And then another gem called cool. And at the time when you developed the program, which was in 2013, okay, the version number that you used for mark was 1.0.1, and for cool was version 2.0. Okay? You see, problem occurs when somewhere down the road Okay? You take this application and then you try to install it or develop it sometime later. Normally, if you did not have bundler, okay, what will happen is that your Ruby program will try to fetch the latest version of Gem, MarkGem, and CoolGem. In 2015, and gave me a lot of headache. For those of you who ran into that problem, I might just let me know so that I can tell you what the problem is. If you guys don't want to run into this headache, installing Ruby version 1.9.3 is okay. 1.9.3 will work as well. Some of you might ask like, hey, how come there's other things like, you know, JRuby, GoRuby, all these, Rubinius? These are simply just different runtimes, okay? But the one that you will be using for this class is the MRI Rubies, okay? So how do you know if you have your Ruby installed correctly? So let's say that you install Ruby version 1.9.3. When you type in Ruby -v, you should see the version number on your screen, okay? All right, so that's a quick rundown of what you can do with RVM. Like I said, these tools or these commands will come in handy. And I even included the URL that you can follow to go through the installation instruction. It's on the bottom right of the slide. We are going to keep going now. Pain your next. All right, RubyGem. RubyGem is another tool, just like RVM, that allows you that you run from the command line. And the reason why you want to use RubyGem is because it simplifies the process of installing Ruby gems from the internet. First thing first, in the Ruby world, we don't call things libraries, we call things as gems, just to fit with the theme of, you know, Ruby, since Ruby is jewelry. So think back to the days that you were using Java, right? If you wanted to use a library off of the internet, you must go to some website to download that library. And it comes in forms of source code or jar file. You download that, and then you have to go to your download folder, grab the jar file or the source code, compile it or whatever, and then link it, right? Include it as part of your Eclipse project jar libraries. But you see, with Ruby gems, that process is streamlined for you. So let me show you how, for example, you would install a library or a gem from the internet. And this is going to be live demonstration. So, the gem that I want to install for this example, let me take off this, hold on, slide, edit. Oh, right here, hide, comments, hide. Okay, so the library or the gem that I want to install is called Maruku, okay? This gem allows you to convert from the Markdown markup language to be an HTML document. How do you install it? So let me show you. Oh, let's see. Oops. Okay, so how do you install this? very easy. First, make sure that you have gem installed on your machine, right? As long as you can type gem, you're good to go. Now, if you want to install Maruku, you simply just execute this command, gem install Maruku. And if God is on our side, then this will be successful. So you see how gem, not only that it tries to install Maruku for you, but it also works out the dependency. Because a lot of times, libraries depend on other libraries, right, or other gems. It will take care of installing all those dependencies for you as well. So how do I know that Maruku is now installed? Well, if I type in Maruku right now, it actually works, right? Like it doesn't do anything because you actually have to supply some input, right? So we're going to stop that, and we are going to use it, right? You can either type Maruku and then pass it the markdown document, okay? Or you can run it from the Ruby program. But let's take a look at how you would run how you would use Maruku gem in the terminal. So let's go to so I have here okay, so I have here I've prepared a markdown file for you guys already, and it's called example.md. So I'm going to remove the previous HTML that I generated. So let's take a look real quickly at what the example markdown looks like. So this looks like a regular, so a markdown or a .md file is just like a regular text file, a .txt file, except that it actually has syntax associated with it. You can actually have a program to transform this text document to look like something that looks more like an HTML document. So the point is not to show you what a markdown document is like, but to show you what happens when you use a gem installed from the internet. So you type Maruku and pass in the markdown document. Oh, crap. So it generated the example.html. Let's take a look at what that does. By the way, for those of you who use terminal on the Mac OS X, to open any file, you can just type in open, and then it will attempt to open that file using whatever default application. So, for example, you have HTML file, right? We can just use open and see what program it uses. My computer, I set Chrome to be my default web browser. That's why it opened the HTML document using Chrome web browser. So you see, essentially what Maruku did was that it transformed example.md from this text file into this, an HTML document. So the point is to show you how easy it is to install a gem from the internet. You would simply just type in gem install Maruku or whatever gem name that you want, and then you can use it from the terminal program, or you can use it within a Ruby program. Now, how do you uninstall a gem that you just installed? Well, very easy, right? Should be intuitive. Oh, I messed up. So to uninstall, you would simply just type in gem uninstall and then passing in the gem name that you want to uninstall. There. You see how easy it is? So you don't have to like fiddle around with the downloaded jar. To simply uninstall something, you would just type it into the terminal. And this is the power of Ruby Gems that I wanted to let you guys know. All right, next thing is Bundler. Bundler is simply a program that tried running Java from command line. You know that once you have the class file, you have to type in Java space and then the class that you want to run. So now I think you guys should be well aware of the difference between Java and Ruby now in terms of running, executing the code. I actually had prepared a video to explain the difference between an interpreter and a compiler, but I'm afraid we don't have time to dive into that, so I'm going to summarize quickly. For those of you who want to understand this, I strongly recommend you to take a look at the YouTube video in the link provided below, but I'm going to quickly explain the difference between an interpreter and a compiler. You guys all know what a compiler is, right? In the world of Java, you write source code, right? .java file. It goes through a compiler. What does the Java compiler produce? Bytecode, exactly. And then bytecode, how does that get run? JVM, perfect. How does the JVM, you see, for the JVM to make use of the bytecode, the verb is interpret. It needs to go through the bytecode and interpret that bytecode so that it will produce the machine code to run on the hardware. Java has all these steps, starting from the Java source code that you write, goes through the compiler, which gets produced as bytecode, and the JVM is what interprets that bytecode, compiles it to be machine code, and then finally your program would get to run. But you see, Ruby is different. Ruby is not like Java. Ruby skips straight to bytecode. So Ruby .rb file, there's no compiler. This code is interpreted by the Ruby runtime. I don't know if it's RVM but Ruby runtime. Oh, no, I'm sorry, it's not runtime, it's interpreter. In other words, there's a program. When you type in Ruby and then you pass it the file name, essentially what happens is that program goes through your code line by line and then execute whatever instruction you put in there. So in the previous slide we had puts, whatever, right? There's no compilation. It simply just interpret and then execute the code line by line. This is the difference between compiler and interpreter in that compiler needs to go through the entire source code to produce something before it can be run, right? But interpreter runs it right away, line by line. That's the difference between compiler and interpreter.
Is that make it faster?
Okay, so it's faster in the sense that your program runs right away. That's the pros of interpreter. But the downside is that since instructions need to be interpreted all the time, Ruby performance is slower compared to compiled languages like Java. On the other hand, the penalty that you pay for programming languages that need to be compiled is the large compilation time. You see, you guys develop a small to like medium-sized application, but imagine a program like Eclipse, where it's like probably 1 million lines of code. To compile Stuff in here, in the bracket, represents the code block that you want to execute for each item. Each item in this case is food. Okay. And lastly, and this one I thought was pretty good. All right. What is this number? Ja is not here. Hey, you in the back. How big is that number? Well, let me ask you, how many zeros? Actually, this is a better question. How many zeros are there? 9. Very quickly, you can discern that there are 9 zeros, right? But you see, in Java, you cannot do this. In Ruby, when you have numbers, you can put underscores, right? But in Java, you cannot. And this is helpful when you have like a large number, right? Actually, in the latest Java version 8, you can put underscores, okay? But it's not officially out yet. So these things make code easier to read, and you can understand the code quickly because of these kind of features. All right, take a look at this has been discussed a bit already, but if you wanted to create an empty program in Java, you still need to have the class and the void main, all that, okay? Whereas in Ruby, you can open a text file, you don't have to type anything in, and it will still be a valid program. It just won't do anything. And you guys are familiar with the getters and the setters, right? In Java. You see, in Ruby, you can basically condense all of that, have the code auto-generated for you by using that ATTR accessors. You see, because for each of the center and radius, it will generate getter and setter for you. So the point from this slide is to show you that Ruby provides you with facility to make your code concise. Why do you want to hello? Why do you want to have to repeatedly type in the same stuff like get radius, set radius, where you can just declare that, okay, I want these attributes to have the getter and setter down there. And by the way, on the next slide, when you have a variable that is prefixed with a colon, we call that a symbol. So let's take a look at what is a symbol real quickly. Whenever you see a symbol, okay, symbols are simply string, with the exception that they are immutable. So you cannot change the value. Every occurrence of the same symbol corresponds to the same single object, okay? While for string, right, even though it's the same string, same value, they refer to different objects. And I'm going to have an example to show what I mean by this. So because of this, because all symbols, they refer to the same symbol, it's a bit cheaper and a bit faster to use. Let's take a look at a concrete example to demonstrate this. You see, I'm not going to run this, but the key that I want you to take away from this is that the first two lines, we're talking about toString, right? String. We print out the object ID. They refer to different object ID. Do you guys understand what we mean by object ID? In the memory space, visually, this is what happens. This is string. This is another string. Even though they contain the same value, but they occupy different memory addresses. But here, the symbol, the object ID for symbol always refers to the same thing, the same one. Is that clear? This is why when you run this program, you see that for symbol, they print out the same object ID, 132178. Whereas when you print out the object ID for two different strings, those refer to two different strings in the memory space. Is that clear? That's the difference between string and symbol in Ruby. Okay? So don't be surprised when you see colon and then some identifier. That simply denotes what? A symbol. Okay? And by the way, it doesn't have to be colon symbol, okay? It can be colon string, colon whatever name you want. Is that clear? Okay. Here's an example of how to construct a list in Java, right? You declare a list of some type, and then you need to add what type? You need to add string to that list, because you declare that this list using generics must contain string, right? On the other hand, how do you declare an array in Ruby? You simply just do a bracket on that line, right? Stuff is equal to array or the bracket. Immediately, that turns into an array. How do you add items to that array? Well, there are many ways. You can use the left arrow, like left shift, to essentially add string into that array. You can declare the array like this as well, or like this. There are actually two ways to create an array of string. %w, parentheses, followed by all these stuff. They're all the same thing. So you guys can go home and try to run this. But the point that I want to make on this slide is this. In Ruby, just because you created an array does not mean that they all have to have the same type. In this case, they're all the same type. The type of each element is a string. But you can actually have an array of string, number, classes, objects, whatever. That's the characteristic of a dynamic type language, is that you can mix whatever type you want. That can be both good and bad. Good in that it's flexible, bad in that you can run into trouble if you mix different types, right? And in general, we don't want you to mix different type that are totally unrelated into the same array. So we've covered this a bit. 3.times, right? We say that this is an object because by definition, an object is something that has methods. And in this case, even a number 3 is an object because it has a method. Self is this operator in Java. So you guys can write that down. You guys are familiar with this operator in Java. Self is the Ruby equivalent. Okay. .class simply just returns the object. So you guys don't have to know this, but we wanted to just show you that even things like the this operator or the number, all right, okay, is an object in Ruby. Dynamic typing. If you guys have been paying attention, you'll notice that compared to Java, you do not need to declare the type for each variable. In this case, def len parentheses is what? What is this? What do you think this is? Who else? Java's not here. Okay, Ploy, you came late, so you get the short story. What do you think len on the top? What is it? Is it a variable? Is it a method? Is it a function? Is it the top box? Huh? No, len. The def len. What is that? I know my question is not that great. But okay, you're trying to say the list is an array, right? Okay, that's good because the name implies. Yeah. So she said it correctly. I mean, it is a method, but to be more precise, this is a function. If you remember, the difference between a function and a method is that function just stands by itself, whereas a method has to belong to a class. But there's no class, so we call that this is a function, but you still have the correct understanding. What am I trying to get you guys to understand from this? Look at x is equal to 0. Can you tell me what is the type of x? Nit? What is the type of x? Int. Did you say int? X is equal to 0. Int, right? You know that because you made an assignment, right? There's no need to declare int. Compare that line to the line below. This is what we mean by dynamic typing. You do not need, you don't declare the type for all variables. All types are inferred based on the assignment. Okay?
What is that?
Def is how you would declare or define the function or the method. So this is the syntax that you use to declare a function in Ruby. Oh, another thing. This function is actually wrong. There's no return value. You know how like, if you what's the return value for the bottom function? Int, right? It must return some value. But you see, in Ruby, here's another thing. You don't declare the return type. You don't know what the return type is for len, right? There's no return type. But what is the key? The key is that for Ruby functions or methods, it will return the type that is the last statement in that function. And if there's nothing, how should I say? If there's nothing explicitly defined, it will return nil. But the point is this, you don't declare return type in Ruby. Not like Java. Java you have to declare, right? And that's sort of like what I want to get across for this slide. Duck typing. Oh man. Okay, by duck, okay, hold on. I need to fix my slide. All right, real quickly. What do we mean by duck typing? By duck typing, we mean if it walks like a duck, quacks like a duck, then it is a duck. What do we mean by that? We mean that if any class, we don't care, as long as it implements the, in this example, if it provides the quack method, the class provides a quack method, then we say that it qualifies to be a duck. The point that I want to get you guys to get away from this is that there's no inheritance. Class A duck and B duck are not related at all. The only commonality between them is that they both provide the quack method. And you see, because Ruby is a dynamically typed language, whatever you pass in, okay, the key is down there. Whatever you pass in, as long as it supplies the quack method, it will work. Compare that to what? In Java, what do we use to enforce that that particular class provides the quack method, for example? Interface. Do you guys remember that we use the interface to enforce that all class that implements this interface must provide those functions or methods? In Ruby, you don't have to. As long as your class actually provides the method that the function is looking for, you're good. So you can put all this inside like a file, a text file, and just run it. You'll see, and you see the benefit of duck typing. Almost done. Wow. This is actually mind-blowing. When the first time that I understood this, hey, I haven't even explained. Okay, good. So since you were so impressed, the first line, what does it do? What do you think is the output? See, we said, right, in Ruby, everything is an object. One is an object. You see, you might think that 1 plus 2 is just 1 plus 2. In Ruby, how you deconstruct that actually can be seen in the line 5 and 6. It actually is calling a method plus on the object 1, passing it the parameter 2. Do you see that? Plus is not an operator. It actually is a method provided by 1. This is what we mean by message passing. Because in Ruby, calling a function is the same thing as message passing. By message passing, I mean send. So if you guys want to write notes, send is an example. The send is the example of how to do message passing in Ruby, whereas the first one, 1 point plus, that is an example of method or like how it works underneath that simple 1 plus 2. The key that I want you guys to understand is that when you do 1 plus 2, the plus operator does not stand by itself. It is part of the fixed num, the number. We are calling the method plus on the number 1, passing in number 2 as the parameter to that method. If you guys don't understand that, that's okay. And then 1 plus 1 dot send, passing in colon plus. What do you remember? When we prefix anything with a colon, what does that turn it to? Symbol, right? We're essentially saying that, man, get too excited. We're essentially saying that send, we want to send the plus message to 1, passing in 2 as a parameter. And this is not restricting yourself with just plus, okay? You can send any messages to whatever objects. And if the object does not support that method, it will raise an exception saying that no method found or something exception. Maybe I have to spend more time in the next lecture explaining this. But again, I think if you guys understand this example, you guys understand, message passing and method. I'm going to skip this. Block of code. This is actually mind-blowing too. What do you think will happen when you execute this code? Things between do and end, we call that a block, a code block. Now, here's the most important insight into Ruby. Times is a method, right? Taking in as part of the parameter, you are sending in piece of code, the block, to that method. We're not passing in value, we're not passing in class, we're passing in a piece of code to a method. This is probably the first time that you guys might encounter this. In other words, within times, there's some code there that will execute this code block. Again, the key, Nate. I'm sorry, I laughed because I saw your face. In Ruby, not only that you can pass values into a method, you can also pass a piece of code into that method. That's what I want you guys to get away from this slide. And that piece of code, the technical term is called block, a block of code. So this is not like a for loop, okay? I mean, how should I say this? It is the same as a for loop, but it is still different. It is also different. You guys are familiar with this, right? Since I'm talking about this, I might as well explain. Int a is equal to 0, right? This is saving or storing a value, right? When you do b plus a, you essentially, whatever the value of b is, you're adding it by what? 0, right? In Ruby, you can do something like this. A is equal to do print hoop n. You can save a piece of code to a variable and passing it into a function. Think of function or code block in Ruby as a value. That's a value. You see what I mean? I mean, this might be a bit hard to get your head wrapped around in the first time. But just remember this. Function can be value. No, not can be value. Function is a value in Ruby. that can be stored to a variable and passed around. And because of that, you can do a lot of really cool things in Ruby.
So,
Hmm.
so the only time you use end is when you have a block.
The only time when you use end, no, also when you define a class, there are many places where you can use end. But do comes with end. Let's just put it that way. Oh man, we don't have time to go over all these, but I want to here. This is pretty thought-provoking. Were there times when you were programming Java where you wish you could modify the existing Java class to add some method or to take out some method? Okay. Well, even if you said no, okay, with Ruby you can. You can add methods, you can change the behavior of the methods. Now, I'm not saying that you should do this. I'm just saying that if you did need to do it, it is available there. For example, if you wanted to add a blank method to the class string, you can simply just add it by defining, creating a class string and then adding the method into that string. And then you would just be able to use it right away down here. When you create a string. I want to go over the last example and then we're done. So I wanted to show you at least one real-world example that just to show you the power of what real Ruby program looks like. When I assign you guys into groups, I wrote a program to actually assign you into groups. I did not manually assign you guys into groups. Let's take a look at that code real quickly. So first of all, I want to show you the input going into this program. I promise there won't be any grades. It'll just be. So you probably can see that it's just a bunch of names, right? Names, and associated with each name is the group number. So what I wanted to create was a program that would transform this into this. You guys got that, right? I wanted to create a program that would transform this, the text file here, name, and each name is associated with a team number, into this. Can you guys see that? Basically, group number, how many members, and also the names. Right? Let's take a look real quickly at the program to do that processing. And I uploaded this onto GitHub as well. So this is a real program, okay? This is how you create a map. You guys remember the map data structure that has key and value? Okay. I open the file and then I extract for each row the group number. That's the third column, so that's why it's 2. First name and last name, that's row 0, 1. So column 0, column 1. I put them in a hash according to the group number, but I add. This is an append. Okay, and then what do I put in there? I put first name and last name. And then the text content what do I want to write out as a text file? Well, I want to go over each group. Each group has what? It has a group number and the group members. I would write out the group title. Oops. Right? Like group title like this. Group 3, 4 members, right? So you come here. Group number, and then group members.size. So group members is an array. An array has a method called size. This is how you get the number of members. And you loop through each member, and then you simply just print out the member name. At the end, I wanted to add a new line to separate between each group. I just write it out. And then in the end, when the program finishes running, I print out the content of the text file, of what I plan to write to the text file, as well as opening a file. So this is just printing out to the console, and this is opening a text file, setting the write mode to be W, which is write, and then just write out the text content. I accomplished this in 24 lines. And I would like to ask you guys, if you guys were to write this program in Java, how many lines will it take? And that's like a question that you can answer yourself if you wanted to try implementing this. Huh? Yeah, how about you do that? Let's see if you can read your code. Now I know that I should never put you three together. What?
How long did it take to do?
Half an hour, maybe.
How long will it take
Yes.
to copy paste?
I didn't copy paste, man. What are you talking about?
No, I mean, did you copy paste?
Oh, dude, how long will it take? There are 53 students in the class.
5 seconds for
Yes.
very fast.
Well, I mean, I'm not good at copy pasting, so it would take me a long time. But for those who are quite skilled and experienced, probably it would take, 10 minutes or something. Anyway, so that is there for you to check out, okay? And that is all that I have prepared for today. And the last thing that I wanted to mention is the homework. So who has taken a look at the homework? So you know what you guys are up against. For those of you who have not taken a look at the homework, and especially for those of you who have been sleeping throughout the whole lecture, I just want to let you know that for homework 9, what you have to do is take the Echo Server and Echo Client.java, those two programs that we cover in the first half of the lecture, and translate it into Ruby. So you will be writing a multi-threaded, socket-enabled application, both server and client. You are supposed to submit 2 files. One is the server, one is the client, and all the code has to be written in Ruby. Good luck.